Alrighty, this is going on page 99 when we're done. Alright, so, surface area pyramids. So our first definition is of, bless you, a pyramid, which we've already had the definition, so I just wanted it on the specific things for pyramids here. So a pyramid is a polyhedron formed by a, bless you, polygonal base, which means the base, bless you, can be any polygon, and triangular lateral faces, plural, that meet at a common vertex. Okay, so the base can be any polygon, including a triangle, but the lateral faces are always triangles no matter what. They could be equilateral, they could be isosceles, they could be nothing special, just triangles, just depending on the pyramid, but they are definitely triangles. Okay, so then the next definition here, it's the point opposite the base. So the point opposite the base, what do we call that? The vertex, right? It's like the vertex, okay? So the vertex of the pyramid. There are other vertices, but that is the vertex. So if we have a pyramid, okay, so a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. Okay, so those are going to be the nice pretty pyramids that you normally see that you're used to thinking of. They're not all like slanted and wonky or whatever. They're all nice and symmetric. This would be a regular pyramid. So the fact that it has a regular polygon as the base makes sense because it's a regular pyramid. But in addition to that, it also has lateral faces that are congruent isosceles triangles. Okay? Everybody okay with that so far? Makes sense? Definitions? So let's look at these pieces down here. All right, so it says blank of a regular pyramid, which is my regular pyramid, is the distance from the vertex of a regular pyramid to the midpoint of an edge of a base. So basically it is this dotted line right here, okay? And it is the distance. So this dotted line, can anybody tell me what that's called? It's not an apothem because that's not a regular polygon for sure. I heard height. Is it the height of the pyramid? No. It's the, okay, but altitude would be, it's either the height or the altitude, but not of the pyramid, of the triangle, right? So it's still an important piece, and it is the height of the triangle, which is going to be important to us, but it also has a special name because it's part of a pyramid. Anybody? It has the word height in it, but it's not just the height. Starts with an S. Anybody? Anybody? Okay. It is called the slant height. I think I heard it. Slant height. That is something that used to not be part of junior high, but I believe it is now. And can anybody tell me what letter we use for slant height? Because it's not an S. No. And it's not H because it represents height, right? So we can't use H because that means height. We can't use S because that means side length, but it also means short leg with special right triangles. So we're already using it twice and it's confusing, and we can't use it again because we'd really be lost. But it is one of the reasons that I think that it is so important that for the area of a rectangle, you throw length times width in the trash can. Because everything is revolved around base and height now, because slant height is a lowercase cursive L like length is. It does not mean length, okay? Does not mean length. It means slant height, right? So this blue dotted line right here, I know yours isn't blue, but mine is. This is the slant height. And it is that lowercase cursive L there. So we don't call it the slant altitude because it is the distance. It's not the segment itself. I mean, those are kind of used interchangeably too. But so the height of the pyramid, where is the height of the pyramid? Through the vertex, right? So it drops down perpendicular from the vertex, right? So it would look something like this. Okay. And it is perpendicular to the base, right? So you notice how I have two things that are perpendicular right now, but they are perpendicular to different pieces. This is a two-dimensional perpendicular thing because it's perpendicular to this edge right here on that. It's drawn on the pyramid itself. This is not drawn on the pyramid. It's like hanging down inside. We can't draw it on the pyramid. Everybody with me on that? Okay, and then I'm looking for my big... So on this thing that I've used forever, and then I dropped it and it's all cracked, but you can kind of see where I drew that line. So this is the slant height. It is drawn on it. The height itself is going to hang down inside of it like this. Does that make sense? You see the difference there? Now, let's say that I give you the height, and I'm looking for the slant height. I can connect these. If I connect these two, what did I just make? A right triangle, okay? So because of that, are the slant height and the height ever going to be the same length? No. Which one's always going to be longer? The slant height. And that triangle is also not drawn on the pyramid. It's hanging down like a curtain in the room. Does that make sense to you? It's like a divider in the room. This length right here, what is this? It's the apothem. It's not the radius. If it was the radius, it would go to a vertex, right? This is the apothem. So if you had the apothem and the height, could you find the slant height? Yes. If you had the slant height and the apothem, could you find the height? Yes. Okay. And you would do those things doing what? Pythagorean theorem. Yeah. Trig might have to come into play depending on what information you're actually given, and I actually could use trig there too. It would make it harder, but I could. But I could maybe give you an angle in one of them, and then we could find the other two. But this is your right triangle here that's kind of floating inside of your pyramid. Okay. All right, so the next one says blank is the segment from the vertex to the plane of the base that is perpendicular to the plane of the base. What is that? It's altitude. So why did you say altitude and not height? Because it says segment. Good. The altitude is the segment. The height is the length of the segment, just to get technical there, but we do use them interchangeably. So this is the altitude. But we use the H for altitude. We don't use A because we really call it the height when we're talking about the length. Then I'm going to draw on there. What would this represent? Slant height, right? So what letter do I use? L, the lowercase cursive L. And then I can connect these two, and what is that? Yes, I do get a right triangle right here, but this length right here is the apothem. This is what? This side length, so I use what letter there? S. Okay. This is a regular pyramid, so what is the shape of the base? A square, okay? So this is a square. A, that little piece there, A, that is the apothem. Yes, we all agree with that? Goes from the center perpendicular to the side there. But for a square, what is this also represented as? What else could I do besides A? What, use some letters that are there that's not Pythagorean theorem. What could I label that as instead of A, using what's already there, but I'm not talking Pythagorean theorem? Don't overthink it. It's real easy. 1/2 S. Isn't this just halfway across here? Okay. It's just half of S, right? So I don't have to be all fancy and complicated to get the apothem. It is the apothem, but in a square, it's just half of the side length. Is that going to work over here for this hexagon? No, it absolutely is not. It's a totally different way of thinking about it. But that could be represented by two different things. Does that make sense to you? We all good with that? Any questions? All right, so I'm going to give you another thing where your nets go, and we're going to come back to this in a minute. You should know how to glue these down, so you could probably go ahead and glue them down. I think I could trust you. It's, you know, like I said, kind of gluing for done, although, oh no, it works. I just had this bad feeling that I printed the wrong one out, but I didn't. I would go ahead and fold this beige paper in half before I glued if I were you. It's just going to make it easier to handle. All right. And then right, so I'm going to fold this in half. This is going on page 98 when we're done. I'm going to go ahead and fold my figures here. And both of these, the green and the pink, make what? Pyramids. I know it was a really hard question because that's what we're talking about right now. So I'm going to go ahead and glue mine down. Then we're going to label some stuff on here. Alright, so I tried to take a really long time here, so I should have given all of you plenty of time to get yours folded and glued down. And whether your lines are on the inside or the outside, it doesn't matter. It's just easier for you to see my stuff if my lines are on the inside. If yours are on the outside, that's fine, because you can see your creases. It's just hard for you to see mine. Alright, so this first one, if these are both regular pyramids, this is a regular pyramid, but it's what would we call it? A square pyramid. Okay, good. So this square pyramid has 4 lateral faces and 1 what? Base. Okay, so this is my base. That is big B. Okay. These lateral faces, what do we know about them besides the fact that they're triangles? They're congruent, and they are what kind of triangles? These might be equilateral, but isosceles for sure. Yeah, it's possible that they're equilateral, but they're isosceles for sure. So if I want to find the lateral area, right, that's the lateral area is everything but the bases. So really it's just the area of the triangles, yes? Does that make sense to you? So do you know how to find the area of a triangle? Yes. How do you find the area of a triangle? Good. It is 1/2 base times height. All right, so the triangle, the base of the triangle here is what part of the pyramid? The base of the triangle is what part of the pyramid? The side length. So this right here actually represents S, right? The height of the triangle is what part of the pyramid? The slant height. Good. The height of the triangle, the height of a lateral face, is the slant height of the pyramid. There's your L. So if you have it drawn like that, fold this one up and draw the slant height on the outside of that triangle, so that when you fold up your triangle, you can see how the slant height can actually be drawn on the pyramid itself. The actual height cannot, because it's hanging down in the middle. Okay. And then also maybe we'll do that on another one. Let's do that on a different triangle because it's hard to do it on that one. That this represents S. Okay. There's your side length. There's your slant height. You can see that when your pyramid is built. Okay. So instead of 1/2 base times height, if I'm going to use variables that apply to my pyramid, what am I going to do? What do I do instead of base? 1/2 S, and then the height of the triangle is what? L. Okay? Everybody with me on that? Now, that's to find the area of one triangle. But I need for the lateral area to have all of the triangles. In my green one, I have how many? 4. In my pink one, I have how many? 3. If it was a pentagon, how many triangles would I have? 5. Okay, so what do I need to use to generalize it? N. Okay, good, a variable, which we'll use because N represents the number of sides. So my lateral area is N, however many sides it has, times the area of a triangle, which is 1/2 S times L, right? So I'm going to rearrange things, and I'm going to make that 1/2 N times S times L. What does N times S represent? Perimeter. N times S is the number of sides times the side length. That's just the perimeter of the base, right? So to substitute in perimeter instead, my lateral area formula looks like this. Lateral area is 1/2 perimeter times slant height. There's your lateral area formula right there. The lateral sides are always triangles for a pyramid, always. And these formulas work for regular pyramids, so that means that P represents that however many triangles you have times the side length. This is just like 1/2 base times height. This just puts all the bases together. Okay, everybody okay with that? Easy enough? All right, so let's label some stuff on our pink one. This is the height of the triangle, which means it is the slant height of the pyramid. This is the side length. This is big B. And then also do the slant height on outside of one of these. And then I'm going to do the side length on the outside of another one. So, okay, so got my side length there to represent it. You really can't do it all in one. I'm just thinking it'd be kind of a little bit too much. And so when you have your net, can I represent the height of my pyramid on my net anywhere? No, it'd have to be like a piece of string that I attach to this or something, and then when I fold it up, it would just hang down there in the middle. Okay. Now, off to the side over here, I want you to write that S is equal to the side length of what? The base. Okay, so it does represent the base of the triangle, but it's the side length of the base of the base, right? It's just the side length of the base. That L is the slant height, but the slant height will always represent the height of a lateral face. So it's always the height of the triangle, and it's the slant height of the pyramid itself. Any questions about any of that so far? Do you understand where it comes from? Because understanding where it comes from is going to help you have a better understanding of what it is in the end when you have to remember all this stuff. All right, so let's go over here and fill some of this in. Lateral area is 1/2 perimeter times slant height. That's what we just came up with. We came up with that formula ourselves. That's the actual formula. To find the total surface area, well, what's missing from the total surface area when we find the lateral area? The base. In a pyramid, how many bases do you have? One. You know what the most common mistake is in finding surface area of pyramids is doing 2 times big B, because that's what you've been doing with prisms. Do you know that there's only one base on a pyramid? Yes, you do. I know you do, but those are just one of those things that just happen, so you need to be careful. So I've got two versions of the surface area formula. I could say lateral area, oh goodness, no, we want that to be surface area. Surface area equals, sorry about that. If I already know the lateral area, then I'm just going to substitute that in, and then to the lateral area I have to add just big B, just one of them. And I have to be very generic again because the base could be any polygon. Or if I don't have the lateral area, I'm just finding it from scratch, then I can do 1/2 perimeter times slant height plus big B, which means I'd need the perimeter of the base and the area of the base, and then the slant height also to substitute all that in. Okay. We all good with all that? Any questions? Alrighty, let's go back to the other notes. All right, so we've got these two pyramids. This first one is a regular pyramid. The second one is leaning, so it is what? Oblique. And so this is an oblique pyramid. However, I'm going to classify it differently because we really need to classify not necessarily between, we're not classifying between right and oblique, because that's either, you know, it's standing up straight or it's leaning over kind of thing, but regular and irregular. I gave you this example for an irregular pyramid because the base is still a regular polygon, but it takes more than being a regular polygon to make it a regular pyramid, because the faces would also have to be congruent isosceles triangles. Those over there very clearly are not. Some of them are isosceles triangles, but not all of them, and none of them are they're not all congruent. Okay, so we have regular and irregular, which it also is oblique, but it could be irregular also because the base isn't a regular polygon. All right, so then these points right here, what are these things called? The vertex. Okay, so this is the vertex of the pyramid. And I tried to make these lines long so that we could just write it once and it kind of take care of both of them. These are pointing to one of the triangles, and the triangles are called what? Lateral faces. Okay, so this is a lateral face. What is this blue dotted line here? Slant height. So this is the slant height. And every time we write those words, we're also going to write the L so that we can keep that straight in our heads. And then these are pointing to base. Everybody good? You know your pieces of pyramids? All right, so here is where we're going to put our formulas that we already came up with. Lateral and surface area of regular pyramids. So these formulas are only going to work for regular pyramids. We know that lateral area, we just came up with that. It kind of looks like 1/2 base times height, but it's 1/2 perimeter of the base times the slant height. Total surface area can be lateral area plus what? Big B. That's one of them. Or the surface area could be 1/2 perimeter times slant height plus big B. Okay. This is the side length. That, of course, is big B, and your slant height is already labeled for you. Okay. We okay with that? Any questions? Up here? Got it? Okay. All right, so let's look at this. It says, find the lateral area and surface area of the regular triangular pyramid with base edges length of 30 centimeters and lateral edges of 20 centimeters. So I need, it says lateral area and surface area. So we'll start with lateral area. So lateral area is 1/2 perimeter times slant height. So can I find the perimeter? Do I have enough information to find the perimeter right now? Well, what is the only thing I ever really want the perimeter of? The base. So that's a good question. So the base. So it tells me the base edges are length of 30, and it's a regular triangular pyramid. So what kind of triangle is the base? If it is a regular triangle, what kind of triangle is it? Equilateral. So the base is an equilateral triangle because all the sides are congruent, all the angles are congruent. The lateral faces are congruent isosceles triangles. Those are two different things, right? So I can find the perimeter of the base. Would you agree with that? Perimeter is just n times s. What is n here? 3. What is s? 30. Okay? So the perimeter is 90. Did they give me the slant height? No. They gave me the length of an edge, a lateral edge. That is not the same as the slant height. Now, I want to make sure you all understand this picture here. How many total triangles are in this pyramid? 4. Okay, so do you see how one of the faces is facing us, right? Now I can draw the slant height on any of them. It's going to be way easier to draw the slant height on the face that's actually in front of us, right? So my slant height goes from the vertex perpendicular to a side here. That is my slant height. I need that. I don't have that, right? So do I have enough information to find it? Am I going to find it in the same way that we talked about on the front of the notes with the apothem and stuff? No, because this is just a two-dimensional kind of thing here. This slant height, I have to use that 20 because that's the other piece of information I have. And this length right here, what is this length? 15. Oops. Sorry, I'm leaning. Oh, come on. All right. This is 15 because this is an isosceles triangle, so I know that this is 20 over here. That's why I know it gets cut in half because we don't always get to just bisect the sides there. So how am I going to find the slant height? Pythagorean theorem. So L squared plus 15 squared equals 20 squared. So what's L squared is L squared. What's 15 squared? 225 equals 400. So L squared is equal to what? 175. So L is the square root of 175. Okay. You got $1.75. How many quarters do you have? 7. So this is really 25 times 7, right? So L is 5 square root of 7. Okay, so there's my L. I need that. I boxed it like it was a fancy, important answer in it. I mean, it's important, but it's not really my final answer. You don't necessarily have to box it. But I'm going to I can come back over here and substitute this in. So now I get 1/2 times the perimeter, which is 90, times the slant height, which is 5 square root of 7. Now, I could take half of 90 right here, but I think I'd rather multiply 5 times 90 than 5 times 45. Would you agree with that? So what's 5 times 90? 450. And then half of 450 is 225. So I get 225 square root of 7 centimeters squared. There is my lateral area. Now I need to find surface area. So my surface area, I already have lateral area, so I'm going to do lateral area plus big B. What is the shape of the base here? Triangle. So my big B formula is 1/2 base times height. Okay. Do I have the base of the triangle? Yes. Do I have the height of the triangle? No, I do not. I don't have the height of the triangle that represents the base. I have the height of the triangle that represents the base. Now, it's an equilateral triangle, which is a regular polygon. Do I have to treat it like a regular polygon with apothem and stuff? No, I do not. And with this information, I think that I wouldn't, right? Here's my base. This is 30. I know that these are all 60, right? So when I go to find the height in here, is the height pretty easy to find? Yeah, because I've got special right triangles, right? What's the height of this triangle? 15 square root of 3, because this is 30, this is 15, and so that makes this right here 15 square root of 3. With an equilateral triangle, that should be something that's pretty easy for you to come up with at this point. So now I substitute this in, and I get 1/2 times the base, which is 30, times the height, which is 15 square root of 3. Okay. And then, so big B is what? $225 square root of 3. And there's big B. So I have my lateral area, and I have my big B. So now for my total surface area, I just put all that together. Lateral area is 225 square root of 7 plus 225 square root of 3. Can I combine those? No, I cannot. I need my parentheses and my centimeters squared. Any questions at this point? We good? All right. Let's move on to the next one. All right, so we're going to find the lateral area and surface area of the regular hexagonal pyramid. What the heck? I hit it twice. Oh. We'll get there. Hang on. Okay, there we go. So I'm going to start with my lateral area. Lateral area formula is 1/2 perimeter times slant height. So I need the perimeter of the base. That's going to be N times S. Do I have enough information to find that right now? Yes, I do. So N is what? 6. S is 10. So my perimeter is 60. Okay, just like I have told y'all before, if you don't actually go off to the side and find the perimeter, you're going to make some mistakes, and I saw that a lot yesterday. People found a side length and were using that as the perimeter because it took you some work to find the side length sometimes, so be very careful. Make sure perimeter's easy, but you have to actually do it, and some people were not, and they were confused about why it wasn't working out. All right, did they give me the slant height? They did. A lot of times, most of the time they don't. So they gave me the slant height. This is not so bad. So I get 1/2 times the perimeter, which is 60, times the slant height, which is 16. Right? So what do you want to take half of? 16. So I get 8 times 60, and my lateral area is 480 inches squared. Everybody good with that? So now I have to find the total surface area, and my total surface area is going to be lateral area plus big B. So is my big B formula 1/2 base times height? No. The base is a regular hexagon, so my big B formula is AP. Good. Did they give me the apothem? No, they did not. Did they give me the perimeter? Well, did they give it to me? No. But did I already find it? Yes. Now just make sure if you found a perimeter, it's really the perimeter that you want to use. This is the perimeter of the base, right? And isn't that what I need here? Yeah, so I'm good. I got that. I just got to find the apothem. So I'm going to come over here. I'm going to draw in my triangle like I normally do. My apothem would be right here. What's my central angle here? 60, right? So I'm going to redraw my triangle out here. And remember, the whole idea of redrawing it is so that it's bigger and it's something you can work with that's nice. This big angle is 60, so these are each 30. This is 10. I need the apothem. Is the apothem pretty easy to figure out? Yes. What is it? 5 squared root of 3. Just find this apothem the exact same way we found the height of that triangle on the page before? It's the same thing. Okay, so now I come back over here, and I get 1/2 times 5 squared root of 3 times the perimeter, which is 60. So big B is 150 square root of 3. Everybody good with that? Now I have my lateral area, I have my big B. Need to put them together, and I get 480 plus 150 square root of 3. Can I actually combine those? No. So that is my surface area. I need parentheses and inches squared. Any questions at all? We all good? Yes? All right. So then while I pass out the homework, I want you to look at the next question, and I want you to come up with a plan for the surface area. So come up with a plan for that while I pass out the homework, and then we'll talk about what our plans are. They are always open on the inside. Do you want me to take your watch? Because I will take your watch, just like I'll take your phone. All right, who wants to give me a plan? Listen, you got one? Okay. Okay, like, but how would I write that down? Like, I'm not going to write lateral area of both of them. So what would you write down? Okay. Lateral area, but I can't just put lateral area plus lateral area because it's like lateral area of what? Okay. Okay, and I heard those two different things, and well, I'm going to do both of those things. So we'll do lateral area of the top, I heard first, plus the lateral area of the bottom. Okay, because if you don't do that, that could confuse you depending on how complicated these figures get, right? Because could I find the lateral area of one of them and double it? No, because are these congruent? No, they're not. They gave me lots of information here, but they have different slant heights, so I can't just find 1 and multiply by 2. If they were congruent, I could just do 2 times that. Or I heard 1 and 2, so you can number them. Again, it's whatever makes sense to you. Lateral area of 1 plus the lateral area of the second one. And, however you, A and B, top and bottom, big and little, whatever makes the most sense to you, as long as it's something somebody can follow. Now, somebody give me a different one, even if it's not the one that you would have used. Can somebody give it to me? Tell me a different plan. I mean, you can still use 1 and 2 or whatever. Aiden. Okay, so surface area of the top plus the surface area of the bottom, and then subtract one of the bases. Okay, y'all agree with that? 2 of the bases, okay? And actually, instead of just big B, like, what is the shape of the base? It's a square, okay? So 2, and I'll just draw it. Or you can do 2 times big B. But there's 2 of them that you subtract. Do we understand why we're subtracting 2 of them? If you take 2 of them and put them together, there are 2 layers there. That's why I want you to actually visualize it. Even if you pick up 2 things, like 2 boxes, and they're prisms and they're not pyramids, so that you can think about the fact that you have 2 layers there to take out. I mean, we could even do another one and say surface area of the top plus the lateral area of the bottom minus 1 square. I mean, there's lots of options there. But any of these 3 work. Okay, just as long as you understand how things get put together and taken apart and all that good kind of stuff, all right? Plan is very important. I will be looking for the plans on all of the composite figures along with the work. We're not actually going to solve this one, but if you can get the plan, you can do the work, and this plan isn't that crazy hard, okay? Any questions at all? All right, you have time to glue. You can go ahead and glue both of them in, because I know we haven't finished the nets because we still have to put a cone in there, but you'll be able to do it with it glued in your ISN. That way you can go ahead and get them glued in. That's 98.